Welcome to KBYP's little engineering shop of horrors, where the TR-3 has spent more time operating on its side than it has on its feet. With the third video in the alignment series, the mystery of the VFO transformer alignment and the alignment load. In video 1, I stated that the alignment load was absolutely necessary, and it is, and now I know why. There is the alignment load, a 4700 picofarad capacitor and two 470 ohms in series, which are 500 each, so that's 1,000. And the black gets clipped to ground and the red gets clipped to the input and output of the VFO cam. What that does is make sure that the VFO output is reasonably flat. When I aligned it with the RIT connected, it wasn't flat. I took the RIT off, which was tied to the grid of the VFO oscillator. And with the carrier signal weak, because I had not put the carrier shift in it, I could align it at 3.8 megahertz in the center of the dial range, and it was 175 watts. At 3.5 megahertz, it might have been 2 watts if I was lucky. Part of that was I'd taken the carrier shift out, so the carrier wasn't getting through the passband of the filter as it should, so I fixed that. But the VFO was lopsided, so to speak. And what the load does is makes the alignment at 3.8 megahertz such that the VFO output is essentially flat across its range. I just tested it here with the correct carrier output, and the power output from 3.8 down to 3.5 varies about 5 watts. That's not too bad. That's acceptable, because that's a 500 kilohertz range on VFO. That's a considerable range. I'd mentioned before that when it was in video 2, I had peaked the VFO without the load. It did give a peak, but extremely lopsided. And I wanted to know if, as in the past, when I'd seen a 10 megahertz second harmonic coming out, were there spurious signals coming out of the VFO? So I connected up the Kenwood receiver because it has an S meter. That Yaesu just has a poor bar graph. But coupled that Kenwood receive input around the VFO oscillator tube and listened from 19 megahertz on down, and all I found was the 5.2 megahertz VFO signal at 3.8 on the dial. Didn't find anything else. So that implies that there's, and I specifically looked at 10.4, which is twice 5.2, and there was nothing there. So whatever caused that problem is either gone, or it's gone because it's aligned correctly. I don't know which. Presumably the alignment load makes the VFO output transformer a pass band instead of a peak. But I don't know what frequencies, and I haven't proven that. But just getting it aligned and getting the output flat is sufficient. As I mentioned in video 2, the last step is to do these alignments in transmit. That takes the receive AGC out of the system, but it's good to align it in receive to get it close, to spend less time pounding on the finals. And at 175 watts, it was up to 180 at 3.8. I can smell smoke coming out of the 75 watt dummy load. Gee, I wonder why. Maybe because it's too small. But it's necessary before transmitting with this transmitter to turn the transmit gain down to 0 and key the transmitter in CW and look for 100 milliamps idle drive. If that's off, there can be significant distortion or overheating of the plates. And as you can see, I had it on. 100 mils is not going to hurt the tubes any. They can, by their specs, they can idle like that continuously. It's also good to, before trying to load it at power, to let the tubes warm up on idle. That's heating the cathode and the plates. Just doesn't hurt. Let it key it with no transmit gain for 10 seconds or so. Interesting thing is, this transmitter was putting out about 140 watts. It was highest on 20 meters, which is incorrect. It should be highest on 80 because all amplifiers that I know of, unless they have feedback, they lose gain as frequency goes up. But the extra 40 watts or so has been gotten without an increase in plate current. It still reads 450 milliamps. So that implies that the amplifier has been made more efficient by having correct drive. So another 40 watts for free. Just a fantastic outcome. And I suspect this transmitter should go 200. I don't think it'll go any more. This rig originally had a 6HS6 for V4 for the mixer. That's a high transconductance tube. The max transconductance is about 17,000 micromhos. It's replaced, and in this radio, it uses a 6AU6A, which is about 6,000. So that's a lot less transconductance, less than half. So a next step is to make sure that the rig is aligned totally and properly with good output on all the bands, which means I've got to get a bigger dummy load. I have one. I've made a 2kW dummy load, just isn't connected yet. But get a dummy load that won't burn up, because I can't do it on the air. And then swap that tube and see if the power output changes. So that's it for the alignment. Have fun. KBYP out.